Okay, we're about to start working on example 34. For example 34, A through H, we will be needing the trigonometric identities formula sheet. I took the liberty of, in yellow, just highlighting a snapshot of the specific formula we're going to use. So when looking at these examples, a 2 sine 17 degrees, cosine 17 degrees, and reading and interpreting the formula, you want to know that they're giving you an expanded form of the left side. Theta is equal to 17 degrees, and our job is to rewrite or substitute that theta within a formula. So the formula is sine. I'm just going to use it the way, or rewrite it the way it's written. Theta is 17. I'm substituting that value, and a final answer is sine of 34 degrees. Now this might seem a little odd. I'm looking at identities, but again, let's reread the directions. The directions say, simplify each expression below as a single function of a single angle. Do not evaluate. So this is a single function, 2 sine theta, and this is a single answer, which we did not evaluate. Okay, so now let's move on and looking at B, the same pattern we're going to analyze from left to right. This is the expanded form, cosine pi over 7, cosine 3 pi over 7. Notice that there's a minus sign in the middle. When we look at the formula says the top is minus, the bottom is plus. So first served will be first connected. So if there's a minus sign, that means the original wants us to add these angles. We are to add. And this is the variable. Alpha represents the first angle, which is pi over 7. And following that idea, beta, which is the second angle, is equal to 3 pi over 7. And then we're going to add these two values under the cosine function. And I'm just going to use a different color so that you could see. And this would be pi over 7 and 3 pi over 7. Now we are left to add. We must simplify, and that follows the rules of adding fractions. When adding fractions, the denominators must be the same. And yes, they are for us, so this is going to be easy. The only little tricky component is that you have to realize pi is treated as a variable, and therefore we have to identify the coefficient, which is 1. So we're really adding 1 plus 3, which is 4. Don't forget to put your pi on top, over 7 cosine. And this is your angle, and we'll just box in a solution. Okay, and that's it. It looks harder than what it is, but that is it. Let's go on to C. As we look at C, again, analyzing, I looked, these trigonometric identities are on the inside of the front cover of your testing review packet. Please read. Notice here, looking across, sine, cosine are being multiplied, and then there's a minus. So our trick is to notice we're working with the minus that is second in our formula, so it's going to correspond to the subtraction. We have the subtraction part, which is also the second. These formulas are used for both addition and subtraction, so you have to be careful. But alpha is, as it is written, first come, first served. Alpha is equal to 7, and beta is equal to 3. Okay, and then what all I'm going to do is rewrite the formula, which is sine, and then we're going to do is subtract these numbers, which is in the order that they're written, 7 minus 3, and 7 minus 3, just put this bolded, is 4, and that is our solution, sine of 4. Okay, on to D. D looks tricky, looks very complex. Again, just pause and analyze. And as I'm reading from left to right, I'm looking plus on top, minus on the bottom. Plus on top, minus on the bottom. That means these angles are to be added, the one on top. Okay, so tangent, just copying down that single trigonometric idea, so that single function, which is tangent, parentheses, and just prepping that we're going to have to add. Identifying alpha as the first number is equal to 11 degrees, and beta, our second angle, is equal to 25. Substituting in the order that they're written, 11 plus 25, and if you take your calculator out, you should see that's 36 degrees, and that is the tangent of 36 degrees. And sorry about that drag. This is your answer. Onward to the next problem. Okay, they're getting more complicated. Pause, regroup, and look. Okay, so you are looking for exactly this expression, 1 minus 2 sine squared. So look all over, and if you look at from left to right, cosine, this is read as cosine of the double angle, 2 theta. There are 3 different versions, 1, 2, and then for our purposes today, we're looking at this one. So I'm just going to box it in. And remember, you can write on your test booklet. You can rewrite, do whatever you need to do to be successful and organized. Okay, so right away we should be able to identify that theta is your angle and your theta value is pi over 9. Okay, you are asked to take that angle in that formula. Okay, and I'm just going to substitute pi over 9, and then I'm going to times it by 2, because that's what it says to do. Multiply this value by 2. Okay, I think I wrote something else besides pi over 9, so let me just fix that. Okay, now the rules for multiplying fractions are numerator times numerator and denominator times denominator. So if I were to do that scratch work, that would be 2 over 1 times pi, or 1 pi, over 9. And this would be kind of our background work. Multiplying fractions, multiply numerator times numerator, denominator times denominator, and you get 2 pi over 9. And again, this function is cosine because that's what it says it is. And formulas are designed to substitute into. Okay, F. Looking at F. Getting more complex. Alpha is 8. So let's write it down. Alpha equals 8. Cosine, beta is equal to 5. Be careful with that. All right, this drag is a little pain in the neck. Okay, looking. This is where you have to analyze and be very careful. The top says subtraction. The bottom says addition. Our given is addition, so we're tracking the bottom, which is telling us to subtract. So I'm just gonna write that down and copy. Substitute. Make sure you're in order, left to right, alpha minus beta, and we get our final answer is cosine of 3. This is it. You can choose to use parentheses to organize what the angle is or not. Box in your final answer, and moving on to G. Okay, radicals. Ooh. Do not be afraid. All right, if you're looking for the formulas, again, I went back and you have to scope and you're going to have to look for those specific formulas that match. Right away, it looks like a match inside the radical, which we formally call the radicand. There's a plus sign in the numerator, so therefore theta is equal to 23. Okay, now as we look to the left, the formula on the left, our single written formula, is going to tell us what to do with this theta value. And it says to divide it by 2. So we do what it says to do, so cosine. And all I do is substitute 23. Okay. Now if you want to simplify this, you use your calculator. Very simple. This is maybe some mental path. Let me clear this out, and I'm just going to put 23 divided by 2. Enter. 11.5. That's your answer. Cosine 11.5. And on with the next one. See, these really are not so bad. You just have to be careful when you substitute. Okay, H, complex, I'm looking at sine times cosine plus in the middle. Again, I think we've used this formula before. Sine of alpha plus beta. Look for what sign is in the middle. As I go look in the middle, there's a plus. That plus is located on top, so it says to add the two angles. Alpha is equal to 7 pi over 13, excuse me, and beta is equal to 5 pi over 13. Okay, it says the formula is asking us to look at the sine of these angles and add them. So we're adding from left to right. 7 pi over 13 plus 5 pi over 13. Okay, now we've talked about adding fractions before. The denominator has to be the same. These have the same denominator. So then you just add the numerators. So you're only going to add 7 and 5. So that's going to be 12. Do not forget your pi. It is treated as a variable. Okay? And just write the rest of it and it's fine. Okay, sometimes they put, again, a radian value, the angle value in parentheses. Sometimes they don't. Can be used for organization, which we have here. That is H. Moving on. Okay, 13 is a little complex. Let's look at 13. I'm just checking my time. And here we go. We're given cotangent of an angle. That's not going to help us. All angles live on a unit circle. We need to know what is the ratio for cotangent. So I'm going to write them all out. It seems like we have to use sine, cosine, sine, cosine. So they're going to be very helpful for us. Okay, so sine ratio is y over r. And these have to be memorized. They are not on your formula sheet. Cosine ratio is equal to x over r. Okay, and it gave us this cotangent. I'm going to squeeze cotangent in here. Cotangent is the reciprocal function of tangent, which is x over y. Okay, this domain, our domain is A for the angle, is going to be greater than 0 but less than pi over 2. Tells us we're working in quadrant 1. Okay, and determine the following. Again, to put these values on the unit circle, we have x, which is 12, y, which is our vertical distance, which is 5. We're going to have to find r. In order to find r, we must use Pythagorean theorem. So I'm just going to go ahead and copy the formula, substitute, and let's see what that looks like. Okay, r is equal to the square root of x squared plus y squared. R is equal to the square root of 12 squared plus 5 squared. Let's bring up the calculator and clear it. Be very careful the way you put it in. Second square. You have to use the calculator defaults by opening a set of parentheses. You will have to put another to put that value of x, which is 12. Close the parentheses, square it outside. This calculator has a delay, so I just want to make sure you see that the square has to go outside. And then we need to put plus the second value, which is 5. Close the parentheses, square it. And then you want to close it for the entire radicand. And press enter. And r is equal to 13. We are ready to rock and roll. Okay, so these formulas, as I've listed here, they require to find sine of the angle. Sine, cosine of the angle. So we need to go get these values. So in order to get these values, I'm going to write it right here. So sine of, and I'll circle in red, our sine of this particular angle is y over r. Y is 5. R is 13. Cosine, which you're going to be asked to use, is x over r. X is 12. R is 13. And I believe those are all the ones that we need. Let's get ready to go. All right, the first one is asking you to double that angle. We use the double angle formula for sine, and it will look like this. 2 times the sine of that angle, which we have up here in parentheses. We're just going to substitute 5 over 13. Again, forgive this drag. And then it's going to be cosine of the same angle, which is 12 over 13. Now, keep in mind, there are no variables here. This is we're asked to evaluate this, and we're just going to put this in our good old handy calculator, clearing the previous problem. 2, every time you see fractions, you need parentheses. 5 divided by 13. Close the parentheses. I made a little faux pas, so I'm just going back over to hover over the minus sign, and then I'm just going to type over it. Check it as you go. Continuing and parentheses. This time I'm going to look. It's 12 divided by 13. Closing the parentheses. Checking. Always check. Enter. Nice. This looks crazy. We want an exact value. Math. Enter. Enter is how you get your fractions, and they want exact values here. And we are able to give the readers what we want, boxing in all our final answers. Okay, next one is asking you to find cosine of the double angle. I'm just going to go ahead and follow these rules. It says to take cosine squared value. So what does that mean, a cosine squared value? As I write, that means you're going to take this cosine value that we have here. Cosine is 12 over 13, and you're going to take that value and square it. Then it says to minus the sine square value. We have the sine square value. It's 5. So again, if you're thinking about to write it, the values or the sine or the cosine value we have. So if they're asked to square it, you take that ratio and you square it, and just know how to put these in your calculator, taking your time. All right, so putting this in, clearing the distractions. Parentheses, and remember the square goes outside. Divided by 13. Close the door. Square it. Minus. And you try this with me. It's very important you try to give that comfort of knowing. That's where the confidence comes in. Okay, and I'm just putting this, square it. The formula says to square it, and put it in. Enter. Math. Enter. Enter. Yes, this is the correct answer. Okay. Moving onward, I think we have one more to go. And, two more. So let's go over here. Again, this is the half angle. All we're going to do is substitute. Now, if you analyze it, look at it carefully. One says plus, the other one says minus, and we have to follow those instructions for sine and cosine, and it depends. Let's see what they want us to do. All right, just substitute. and it just means left or right, so all we have to do is substitute. So 1 time. So the formula is here, and cosine was 12 over 13. You're going to use your calculators to figure out the value of the numerator. I would right away let the calculator do it, but if you're doing this for freehand, you have to convert whole numbers into fractions, so there's going to be some extra drama going on here. I'll do it for the first one, and then we'll let the calculators do it. So this will be 13 over 13. A number divided by itself is 1. So all I'm doing is substituting. All of this is still over 2 minus 12 over 13, which is our cosine value. Now we're able to subtract. The denominators have to be the same in order to add or subtract fractions. And this is going to be positive 1 over 13 divided by 2, and all of this value is underneath the radical. Again, a lot of us forget the rules for dividing by fractions. So underneath the radical, I'm going to have this. You take the numerator and you just copy it. Our numerator is the complex number here. So you take that numerator. 1 second. Multiply this value by the reciprocal of the denominator. Reciprocal of 2 is 1/2. So, excuse me. And the final answer, moving forward, is going to be radical 1 over 26. This can also be simplified. When you take a radical of a fraction, you're actually taking the radical of the numerator and a radical of the denominator. And then simplifying this further, 1 is a perfect square, 1 over radical. And this is as far as you have to go. And I'll box in that answer. Okay, I'm going to use the calculator for the whole example for the bottom. So again, just copying. And a plus or minus just means to the left or right. So just respect it by copying it and you're fine. All right, substituting. This is going to be 1 plus the cosine of that angle. And we have that value right at our fingertips. We're just going to change this to plus. Cosine value is written. Okay, some of you might find it easier to just use your calculators to add the fractions, which I'm going to do. I'm just adding 1 plus, and you have to use parentheses for your fractions. Close it, and just press math enter enter. And you get 25 over 13. And that's just for the top. So let's go ahead and write it. And copying and respecting. Again, knowing the rules. Again, you could use your calculator to evaluate. That's what we're going to do. And this says, inside the radical, we're going to take the numerator, which is the complex fraction. It's going to be 25. Oops, you need parentheses. Do not forget, because otherwise you're not going to get the right answer. Divided by 13. And then you're going to divide this fraction by 2. All I did is copy what the original says. Math, enter, enter. And it seems to have done it twice, and you get 25. So if you're savvy with your calculator, you will be successful. 25 over 26. Okay, again, we're taking the square root of a fraction. So you're going to take the square root of the numerator over the square root of the denominator. 25 is a perfect square of 5. So your answer is going to be 5 over radical 26. 26 must stay in a radical. And this is all you're required to do.